Welcome to Day 8 of Daily AI Wizard, your magical journey to mastering AI. I'm Anastasia, your AI guide, here to make learning AI simple and exciting for everyone. Ever wondered what powers AI to make those jaw-dropping predictions? Today, we'll uncover why data is the heart of AI, and trust me, you won't want to miss this. I've brought along a special friend to greet you.
I'm Sophia, your demo guide. Data is the secret sauce behind AI's magic, and I'll show you how it works with a cool demo later. Stick around, it's going to be awesome.
Let's recap Day 7 before we dive in. We explored reinforcement learning, where agents learn through trial and error, following a process of observing, acting, receiving rewards, and updating strategies. We covered key concepts like the agent, environment, and rewards, and Sophia showed us an agent balancing a pole in OpenAI Jim's cart pole game. I hope you tried the task and shared your results in the comments. Now let's shift gears to a foundational topic in AI: data. Today, we'll uncover the critical role of data in AI. We'll explore why data matters so much, the different types of data, and how to collect it effectively for AI systems. We'll also dive into pre-processing data to make it ready for AI models, plus ethical considerations, and a demo to see it in action. Data is the fuel that drives AI success, so let's learn how to use it wisely. This lesson will set the stage for everything AI does. Data is the foundation of all AI systems, making it absolutely essential. AI learns patterns and makes predictions by analyzing data, which is how it gets smart. Generally, more data leads to better performance, as AI has more examples to learn from. For example, AI can predict the weather by studying historical weather data, spotting trends to forecast rain or sunshine. Without data, AI would be like a car with no fuel. It simply wouldn't work. Think of data as the fuel that powers AI models. AI needs data to train, learn, and improve its performance over time, just like we need energy to function. High-quality data leads to accurate predictions, while poor data results in poor AI performance. Garbage in, garbage out. It's like giving AI the right food to grow smarter and stronger. Data quality is key to unlocking AI's full potential in any application. Data comes in different types, and understanding them is crucial for AI. There are three main types: structured data, like tables and databases; unstructured data, like images and text; and semi-structured data, like JSON or XML files. Each type powers different AI tasks, from analyzing spreadsheets to processing photos or web data. Knowing these types helps us choose the right data for the right AI application. Let's break down each type to see how they work. Structured data is highly organized, typically stored in tables with rows and columns. An example is sales data, which might include columns like price, quantity, and date for each transaction. This type of data is easy for AI to process and analyze because of its clear structure. It's often used in predictive models, like forecasting sales trends or customer behavior. Structured data is a go-to choice for many AI applications due to its simplicity. Unstructured data isn't organized in a predefined way, making it more complex. Examples include images, videos, and social media posts, which don't fit neatly into tables. This type of data requires more processing for AI to use, often involving techniques like feature extraction, It powers tasks like image recognition, where AI learns to identify objects in photos. Unstructured data is everywhere, and AI is getting better at handling it every day. Semi-structured data is a mix of structured and unstructured data, offering a middle ground. Examples include JSON and XML files, often used for web data or logs, which have some organization but remain flexible. It's not as rigid as tables, but still has tags or markers to structure the information. This type of data is commonly used in web applications and APIs, like fetching user data. Semi-structured data is versatile for many AI tasks. Data for AI is collected from various sources, each serving a unique purpose. Common sources include sensors, surveys, and web scraping, gathering data from the world around us. For example, IoT devices like smart thermostats collect temperature data to optimize energy use. Data collection must be ethical and legal, respecting privacy and regulations. Volume and variety are key to ensuring AI has enough diverse data to learn effectively. Let's look at a data collection example using IoT devices. IoT devices, like smart sensors, are everywhere, collecting data in real time from our surroundings. For instance, wearables like fitness trackers monitor your heart rate and activity levels continuously. This generates massive amounts of real-time data, which AI can use for health monitoring systems. Such data helps AI predict health issues or recommend lifestyle changes effectively. Data collection comes with several challenges that we need to address. Privacy concerns are critical, ensuring user consent and protecting sensitive information. Data bias can occur if samples aren't representative, leading to unfair AI outcomes. There's also a trade-off between data volume and quality. More isn't always better if it's messy. Legal regulations like GDPR add another layer, requiring compliance in data practices. Before AI can use data, it needs pre-processing to make it ready. Pre-processing involves preparing raw data through steps like cleaning, normalizing, and encoding to fit AI models. This ensures the data is usable, consistent, and free of errors that could confuse the AI. It's a critical step for achieving high accuracy in AI predictions. Think of it as preparing ingredients before cooking a meal. The first step in pre-processing is cleaning the data. This means removing errors, duplicates, and handling missing values to ensure the dataset is accurate. For example, fixing typos in customer data, like correcting John to John, improves consistency. Cleaning ensures data quality and reliability for AI to work with. It prevents AI from learning bad patterns that could lead to wrong predictions. The second step is normalizing the data, which means scaling it to a standard range, like 0 to 1. For example, normalizing income values ensures that a $10,000 salary and a $100,000 salary are comparable on the same scale. This ensures fair comparison across different features, preventing one from dominating due to its size. Normalization improves AI model performance by making training more efficient. It's a small step with a big impact. The third step is encoding data, which converts categorical data into numbers that AI can understand. For example, encoding male and female as 0 and 1 turns text into numerical values. This makes the data usable for AI algorithms, which typically work with numbers, not words. Encoding is common in classification tasks, like predicting customer preferences. It's a crucial step to bridge the gap between human data and AI. When it comes to data, quality and quantity both matter in AI. Quality means having clean, relevant, and unbiased data that AI can trust to learn correctly. Quantity refers to having more data, which can improve learning by providing more examples. Striking a balance between quality and quantity is key for AI success, as too much bad data is useless. Poor data will always lead to poor AI results, no matter the amount. Using data in AI comes with important ethical considerations. Privacy is crucial, so we must protect user data through methods like anonymization to prevent misuse. Bias must be addressed to avoid unfair outcomes, like in hiring AI that might favor certain groups. Transparency means explaining how data is used, building user trust in AI systems. Ethics ensure that AI is responsible, fair, and trustworthy for everyone involved. Data has a massive real-world impact through AI applications. In healthcare, AI predicts diseases using patient data, helping doctors save lives with early diagnoses. In retail, AI personalizes shopping experiences by analyzing user data, recommending products you'll love. Autonomous cars navigate safely using sensor data, making roads smarter and safer. Data drives these life-changing applications, showing why it's so critical in AI systems today. To see how data preprocessing works in AI, let's bring in Sophia for a demo. She'll use Python and the Pandas library to preprocess a customer dataset, making it ready for an AI model. This demo will show the steps we discussed, like cleaning and encoding, in action. It's a great way to understand how data becomes AI-ready. Over to you, Sophia, to show us the magic of data preprocessing.
Hi, I'm Sophia, your demo guide for DailyAIWizard. I'm using Python and Pandas to pre-process a customer dataset with features like age, income, and gender. First, I clean the data by filling missing values, then normalize income to a 0 to 1 scale, and encode gender into numbers. Now the data is ready for AI training. See how easy that was? Back to you, Anastasia.
Thanks, Sophia. That was a fantastic demo. Let's break down how it worked. Sophia used Python and the Pandas library to pre-process a customer dataset, following the steps we discussed earlier. She cleaned the data by filling missing values, normalized the income feature to a 0-1 scale, and encoded gender into numbers for AI use. Now the data is AI-ready, ensuring better model performance. This process is essential for any AI project. Working with data in AI comes with several challenges. Data scarcity can be an issue when there's not enough data to train a model effectively, limiting its performance. Data bias leads to unfair predictions, like favoring one group over another, which can harm trust. Data complexity, especially with unstructured data, makes processing difficult and time-consuming. Overcoming these challenges is key to ensuring AI systems are accurate and fair. Let's recap what we've learned today. Data is the heart of AI systems, powering everything from predictions to decisions with its insights. We explored types of data, structured, unstructured, and semi-structured, and how to pre-process it through cleaning, normalizing, and encoding. We also discussed ethical considerations like privacy, bias, and transparency, which are crucial for responsible AI. Your task: pre-process a dataset using Pandas and share your steps in the comments. That's it for Day 8, everyone. Thank you for joining me on this AI journey. I'm Anastasia, and I hope you loved learning why data matters in AI as much as I did. If this lesson inspired you, please give it a thumbs up, subscribe, and hit the bell for daily lessons. Tomorrow we'll dive into neural networks in action, a game changer in AI. Let's hear from Sophia before we go.
Hi, it's me, Sophia. Pre-processing data was so much fun. Stay tuned for more magic. Day 9 will rock, so don't miss out, wizards.